Everybody, welcome to Optical Communication Engineering class. Hope you're all doing good. So these are the syllabus that has been prescribed in your curriculum. So we'll be dealing with each of the topics in the coming classes. These are the frequently asked university questions that has been picked up. So before going in deep to the subject, we'll have a quick recap on the basics, like what is optical communication, what is an optical fiber, what are the basic principles that guide light through the optical fiber, and what is the different bands used in optical fiber communication, then which part of the spectrum is used for optical communication, so things like that. So we'll be having a quick recap. Okay, so what is optical communication? Optical communication is nothing but a type of communication in which the medium used is an optical fiber. So in optical communication, we have a transmitter, we have a receiver, and the medium for communication would be an optical fiber. So the next question comes, what is an optical fiber? An optical fiber is nothing but a fiber which is made from silica, which permits light to pass through it. So, in optical communication, the medium in which we transmit information is through light. So, the optical fiber has various advantages, which makes it preferably a better option from the other conventional communication mediums that has been using and that has been used before. An optical fiber is a bundle of such glass threads which is made of silica, which is capable of transmitting signals through each of these glass threads. So why we go for this optical fibers from the conventional coaxial cables? Because these are the better bandwidth. The optical fibers are less affected by noise. This is thinner and lighter. It is not very bulky as that of the conventional coaxial cables. It's more secure. It is difficult to tap the signals from the optical line. It's very difficult to tap the signals from the optical fiber, and this is suitable for long distance communication. So you can see from the figure, this is an electromagnetic spectrum that is being used for communication, and you can see that is marked which particular band is used for optical fiber communication. So this is optical band that is being used for optical communication. You can see UV, visible, IR, and the different regions. So basically in optical communication we have three windows: window 1, window 2, and window 3, which has been centered at wavelength 850 nanometer, 1310 nanometer, and 1550 nanometer. So these are the three windows that are used for optical communication: window 1, window 2, and window 3. And to these windows we have named different band: OSC band. So you can see the basic structure of an optical fiber. It has three main parts: the core, cladding, and the jacket. The innermost part is called the core. Covering the core is the cladding, and covering the cladding is the jacket. So an optical fiber mainly has three parts: core, cladding, and jacket. The basic difference between core cladding is the difference in the refractive index. Jacket is nothing but a buffer material to protect the core and the cladding. The optical fiber mainly is made of three parts: the core, cladding, and the buffer. The core is the innermost part. It is made up of glass. Suppose it has a refractive index N1. Usually the refractive index of the core is greater than that of the cladding. Now the part that covers the core is the cladding. It has a refractive index profile of say N2. Usually the refractive index of core N1 is greater than that of N2 for the light to propagate under the principle of total internal reflection, which will be discussed in the later slides. So covering the cladding is the buffer. It provides an extra protection for the core cladding. The material that is being used for the fabrication of a buffer is nothing but a plastic material.